All right, so what we're going to talk about today is the slope of a line. So let's grab your spiral notebooks, okay? We're going to title a brand new page in your notebook, Slope of a Line. So this entire set of notes is dedicated to the different types of slope and all the different ways that we can find the slope of a line, okay? Because that's usually the toughest part when we're going to write an equation later on, is first figuring out what the slope is. So let's start with the definition of slope. What are we talking about when we say the slope of a line? And what we're talking about is the steepness, okay, of that line. How quickly it increases or how quickly the line decreases. So when we talk about slope, there's 4 different types that we're going to see. All right, so I'm going to just set up 4 different graphs right here. Just as a reminder with these videos, if there's ever anything that goes a little bit too quick or you need to stop to write something down, just hit the pause key and resume when you are ready. So the first kind of slope is going to be for lines that look like this, okay, where maybe the line right here is increasing. This is what's called a positive slope. All right, and so if I put a little biker guy on the line, you can see that he is going uphill. So this is going to be a positive slope. Lines with a positive slope are written in the form y equals mx plus b, where m is going to be a number greater than 0. Now, the next kind of slope is a negative slope. Okay. Negative lines with a negative slope are actually going to fall, okay, to the right. And so if you kind of see and you put your little biker guy on here, you can see that the line is going downhill. Diagonal lines with positive and negative slopes are written in the form y equals mx plus b, where we have a slope and a y-intercept. But in this case, your m, or your slope, would be less than 0. Now there's 2 more types of lines that we've practiced graphing, and the next one is going to be a horizontal line. Okay, well, a horizontal line would be like riding your bike down a flat road, and so we would say that it has a slope of 0, or 0 slope. Okay, well, lines that are written in the form, lines that are written as horizontal lines can be written as y equals just some kind of a constant number. So as an example, maybe we could say that this is the line y equals 3. And then the last kind of line that we're going to have is going to be a vertical line. And vertical lines would be like riding your bike down a cliff, which is not going to end well. So what we say about this is an undefined slope. And we will, in our next example, we'll do an example of what causes that slope to be undefined. Now, as a review, vertical lines are always written as x equals, and it just equals some kind of constant number. So again, as an example, this would maybe be the equation x equals 2. And so we've got our 2 diagonal lines with positive and negative slope. We also have horizontal lines, we have vertical lines. So the next thing is we need to practice all the different ways to find slope. Well, let's suppose I were to give you 2 points. Say I give you a point right here in red, and I give you a point right here in red. Well, if we're looking at a graph, all we would need to do is kind of count how far up we go, change in y, over how far we go, change in x. But what if I don't give you a graph? What if I'm just give you 2 points? So given 2 points, all right, so suppose our first point is x sub 1 and y sub 1, and I give you a second point, x sub 2 and y sub 2, okay? We can then use the slope formula to find our slope. So we're going to say that m equals, now what the slope formula says is that we're going to take the second y coordinate and subtract it from the first coordinate. So we're going to say y2 minus y sub 1. And we're going to divide that by, we're going to take this, we're going to take the second x coordinate and divide it by the first x coordinate. And so that is where we really start to see that the slope is the change in y's divided by the change in x, okay? Which is why you'll often hear rise over run. You go up and down first, and then you go over left and right. This is the slope formula. All right, so that's where I want to begin. Let's go ahead and look at a couple examples and make sure that we are comfortable with using the slope formula. So I'm just going to say as the directions, I want you to find the slope. All right, so for part A, the points are going to be -4, 7, and suppose I give you 2, -1. All right, pause it if you need to. Go ahead and copy that down. All right, so when we start this out, let's go ahead and maybe it would help to label, this is your first x, this is your first y. This is your second x, this is your second y. So I'm gonna plug this into the slope formula. And it's gonna go m equals, okay, y sub 2 minus y sub 1. So we're gonna subtract -1 minus 7. All right, you can see right here that I'm subtracting these. And I'm gonna divide that by x of 2 minus x of 1. Now here's where we need to be careful. This is 2 minus, and we're subtracting a -4. Okay, make sure we don't write 2 minus 4. It's actually minus a -4. So in the numerator, -1 minus 7 is -8. But in the denominator, when we minus a negative, this turns it into plus plus, and it's actually 2 plus 4. So our slope is -8.6. But we always want to reduce our slope, okay? And what I notice is we have this common multiple. We can divide the numerator and the denominator both by 2. You can also use your calculator to simplify and use the math frac to turn it back into a fraction. So -8 divided by 2 is -4, and 6 divided by 2 is 3. And so what we have right here is our line, okay? It's a negative slope. We're gonna have one of those lines, right, that falls and falls downwards, as we saw right here up in this example. Okay, so these are the takeaways from part A. We write our slope as a reduced fraction instead of writing it as a decimal or leaving it as -8.6. Let's leave it as a fraction. Let's make sure we reduce it. Let's do one more example. Suppose we have -4 and 2.5, and we have the point -4, 3. All right. Again, we can label this first x, first y, second x, second y. And we're going to use the slope formula. M equals, we're going to take y sub 2 minus y sub 1. And in the denominator, it's going to be x of 2 minus, again, we need to be careful, it's minus a -4. So let's see what happens. 3 minus 2.5 is going to be 0.5. -4 minus -4 is going to turn this into a plus plus. Well, -4 plus 4 is 0. So this is something we need to be careful about when we have a 0 in the numerator or the denominator. So what I'm going to do is let's go over to our calculator, okay? And let's see what happens when we plug in 0.5 and we divide by 0. Now my calculator says overflow error. That's only because I don't exactly have a Texas Instrument calculator on my iPad. Your calculator says error divide by 0. But the point is that we all get an error. So what we need to do is we can't leave it like this. We need to state the type of slope that we have. Because we get that error dividing by 0, this slope is undefined, which means it's going to make a vertical line. That's what's happening with these 2 points, is they're really just on a vertical line. And so in summary here about the 0 and how do we know the difference if it's a 0 slope or if it's an undefined slope, I got a nice little trick for you right here, okay? So the trick that a student told me a couple years ago, and I've used it ever since, is it is okay to have a 0 in the numerator. If it's 0 divided by a number, the slope is going to equal 0. It is a no to put a 0 in the denominator. So if your 0's in the denominator, that's when you're going to have an undefined slope, okay? So hopefully that helps. The next thing that we're going to talk about is going to be parallel lines, okay? Parallel lines and perpendicular lines, which I feel like you talk about a good deal in geometry. But what we're going to talk about is the algebra of parallel lines and the algebra of perpendicular lines. Well, let's review first off what parallel lines even look like. Well, parallel lines, they never cross. And the reason that these two lines never cross is because they have the same steepness. Well, what causes the steepness of a line? You're exactly right, slope. The slope is the same. So if this line has a slope of 2, then this line must also have a slope of 2. Okay? Let's move on to perpendicular. Well, perpendicular lines cross, but they don't just intersect, they intersect special. And what happens with perpendicular is they intersect at 90 degrees. And so I'm going to put this little box right here. So the slopes of perpendicular lines, okay, the slopes are opposite reciprocals. Let's talk about what that means. The slopes are opposite reciprocals. So let's say our first line has a slope of 1/3. Well, the second line then, if it is perpendicular, is going to be the opposite. So it's going to be negative, and where the reciprocal means we're going to flip the 1/3 and make it 3/1. Well, writing 3/1 is really just the number -3. When you multiply opposite reciprocals, okay, when you multiply, you will always equal -1. So if you're ever not sure if something's an opposite reciprocal, you can always multiply the two together and get -1. So the last part that we're going to do, okay, is let's see if I can give you a couple different scenarios and you figure out the slope of the line. So find the slope given. All right. So for part A, this is, if you need to, like I said, I'm going to jot down a table pretty quickly here. I want you to pause the video if needed so you can copy everything down. So I've got this point -4, 2, 4, 8, 8, 11, 12, 14, and I accidentally just made it a little bit too long, so let's just go ahead and do this. Okay. So first thing I want you to do is let's find the slope given a table. Well, if I'm given a table, then what I'm going to do is I'm going to pick 2 points. All right, you can pick any 2 points. So if I got to pick any 2 points, I would pick ones that had easy numbers, lower numbers, 0, or I would pick 2 points that are positive because I think positive numbers are easier to work with than negative. So if we choose any 2 points from the table, we can then use the slope formula, right, where we say your slope is equal to y2 minus y1 divided by x2 minus x1. And so again, just reinforcing our slope formula. 11 minus 8 is going to be 3, and 8 minus 4. And so this is reduced. This is a positive slope, 3/4. Okay, so that's what we can do if we're given a table, is we can just choose any 2 points that we want. Let's suppose that I am given a line perpendicular. So this one I want you to make sure you pay attention to. This is usually where students have trouble. So we're going to find the slope perpendicular to the line. X plus 2y is equal to 8. All right, now stay tuned for this one. The first thing that I need to do is I need to write x plus 2y equals 8 in slope intercept form. Meaning we need to solve for y and write it as y equals mx plus b. I can't look at this equation and see what the slope is until I write the equation in slope-intercept form. Then I know that the number in front of x is going to be the slope. So this is a good chance to review our slope-intercept form. What are we going to do first? We're going to subtract x from both sides. So 2y is equal to, now again, let's get in the habit of putting the x term first, then we'll put plus 8. Then I'm going to divide every term by 2. Y is equal to, now this throws some people here, and I don't recommend that you write it as negative x divided by 2. Let's put a 1 in front of that x. So really what's happening with the slope is it's negative 1/2 x. That's what our slope is. And 8 divided by 2 is going to reduce to be 4. So if the slope of this line, okay, is equal to negative 1/2, then the perpendicular slope is going to equal the opposite reciprocal. So first I'm going to know that it's going to be a positive. So if this is negative 1/2, then our slope is going to be a positive, and we're going to flip the fraction and make it 2/1. Now how should we write this? Do we really need to put the positive in front? The answer is no. Do we really need to put divided by 1? No. So what I'm going to do is I'm going to just say that the perpendicular slope is going to be 2. The thing I want to kind of show you is a lot of people then go, what about the +4? That's just the y-intercept. The y-intercept of this given line really has nothing to do with what the perpendicular slope is, okay? And so that's just kind of another scenario right there. Let's suppose for our last one, let's say that I say it is parallel to the line. Say we have something like 3y equals 5x minus 2, okay? And we need to find the slope that is parallel to the line 3y equals 5x minus 2. So the first thing I'm going to do is I'm going to write this equation in slope-intercept form. Again, I can't just look at it and say the slope is 5 because I don't have this in slope-intercept form. So we're going to divide by 3. Y equals 5/3 x minus 2/3. So what's the only thing I care about with the given line? And that is that the slope is 5/3. The y-intercept of this line has nothing to do with what we're trying to find, which is the parallel slope. Well, the parallel slope is going to be the same slope. So if this line has a slope of 5/3, the parallel slope will also be 5/3, okay? The last thing that we're gonna work on in class is how to find the slope of a line if I give you a graph. But we'll go ahead and continue this discussion in class. All right, so that is it. And make sure you bring your notebooks to class with you. We'll see you next time. Bye.